health engineering. We are going to start our second session on the quality, quantity and sources of water. This is the first unit from public health engineering. So now we are going to learn about rate of demand, demand of water, variations of demands, then how to calculate the populations, mean forecasting of population. Okay, means future population is calculated by using the previous data, okay. Then after that we are going to learn about the different intake structures, then different methods for calculation of population forecasting, etc. Okay, from this unit again we are going to learn about different demands, means public demand, then domestic demand, industrial, commercial, institutional. Fire demand is also calculated by using these concepts. Okay, then there are domestic demand means डे टू डे लाइफ वाटर जो हम यूज़ करते हैं वो. इंडस्ट्रियल डिमांड्स मीन्स फॉर मैन्युफैक्चरिंग, प्रोसेसिंग एक्सेट्रा पर्पस के लिए जो यूज़ होता है वो वाटर हम कैलकुलेट कर देंगे यहाँ पर. आफ्टर दैट there are different methods for calculating this kind of population. Okay, for the population forecasting is also important thing. For the forecasting of this population we are going to use different methods, means like arithmetical increase method, geometrical increase method, incremental increase method, decrease rate of growth demand, and simple graphical method. After that graphical comparison method, zoning method is there, then the logistic curve method. So many methods are used for population forecasting again. Then after that variations of demand of water, means as I told you already in our first session that there are different variations in demand of water, like seasonal variation, monthly, daily variation, hourly variation, that we are also going to learn in this session. Okay, first of all you have to think about the rate of demand. It's a very difficult to estimate the quantity of the water required for particular town or city. So it involves the assumptions of many factors. A designer play an important role to calculating while computing the quantity of water. So there are different topics, means mainly two topics affect on that computing process of estimating that population. So first is rate of demand and second is population. So rate of demand means rate of consumption per head is estimated on required of water for various uses. Okay, then what is exactly meaning of rate of demand means what? The quantity per rate of water to be supplied per head per day is known as the rate of demand. So it's expressed in liter per day per person, okay, or liter per head per day, liter per person per day, liter per capita per day. Okay, we can measure it in this form. And rate of demand is Q upon P by 365. Okay, in first section we studied that how the demand of rate of demand is calculating. Then populations is means rate of demand is dependent on second factor is population. So person to be served or distributed by the scheme are calculated, and the calculated an estimate of future population is worked out by suitable methods. That methods we are going to learn in this session. So rate of demand means Q upon P by 365. This P in that formula, the P means estimated population to be served. Okay, by that whatever scheme, means what supply scheme. Then rate of demand. So this is the main point, rate of demand. So demand of water varies from season to season, then from population. So many things, so many factors which are affecting on this water demand. Okay, so various water demands are following are the various water demands which is shown in this lesson. So water demands are, first is domestic demand, then industrial demand, after these commercial, institutional, fire demand, then loss and waste is there. After that, like public demand is also there. Okay, so domestic demand means water needed for drinking, cooking, washing, bathing, lawn sprinkling, gardening, sanitary. Then residential building demand is in between 50 to 350 liter per capita per day, and it also depends on habits of that people, then living standards of people, then seasons. After they use for means miscellaneous uses is also there. Okay, so all factors are affecting on the domestic demand, and it's majorly in between 50 to 350 liter per capita per day, or a liter per person per day. What you whatever is suitable, you can say this. Then depends upon means habit of people, means living standard. If it is high level society, then people require more amount of water, and if the people living in low level society or medium society, then they require less amount of water than that high level societies people. Okay, so as per IS residential domestic demand means IS standard. Okay, so domestic demand is in is about 135 liter per capita per day. Okay, at 55 to 60% of total demand, breakup of 135 liter per capita per day. So following are the some purposes and water consumption rates. So drinking required 5 liter per capita per day, cooking 5 liter per capita per day, bathing 55 liter per capita per day, washing clothes 20 liter per capita per day, then washing utensils 10 liter per capita per day, house washing 10 liter per capita per day, then toilet flushing 30 liter per capita per day, or means sanitary. Okay, so after that, if we get if we calculate, or if we get the sum of these all, then we get total quantities 135 liter per capita per day. Okay, and in this, so drinking is under normal condition, humans required 5 liter per capita per day. Okay, for cooking same. So bathing is depends on habit of people or the climate condition. So Indian bath, the quantity is assumed is about 50 to 55 liter per day. Then household sanitary purpose, so then about is about means WC, then washing floors, floor washing, then hands, then averagely is about 30 liter per capita per day. Okay, this 30 liter, 10 and 10, about 50 total washing to toilet flushing, it's a 50. Okay, then miscellaneous uses means what, here domestic में और एक होता है miscellaneous uses भी होता है. So उसमें gardening, private vehicle washing, 5 to 10 liter per day per capita. Okay, so it's all its sum is 135 liter per day per head. Okay, or 135 liter per capita per day according to IS. And second is public demand. Second is public. So next is public demand. Okay, so public demand means was road washing, sanitary purpose. Okay, these are all the public demand. Means here sewer flushing is also roadside trees, watering for roadside trees. So the water need for washing the street, swimming pools, these are public swimming pools, public parks, fountains, ornamental displays in city, then flushing of a public toilet and sewers. It may range from 20 to 70 liter per capita per day at 5 to 10% of total demand. And then road washing means road with the heavy amount of dust and sprinkler with the water to avoid inconvenient to users. To average the quantity of water required is about 2 point is about 1 to 1.5 liter per square per day, or we can say that is about 5 liter per head per day. Okay, then sanitary purpose, water is required for cleaning public sanitary blocks, market yard. Its average is about 4.5 liter per square meter per day, or we can say that 2 to 3 liter per head per day. Okay, water is required. Then roadside trees, road washing is also included in public demand. After this, industrial, commercial, institutional demand. So water required for offices, shopping center, hotels, cinema halls, then school, colleges, institutional buildings, then hostels, then hospitals, railways, bus stations, and various industrial purposes known as the industrial, commercial, and institutional demand. So here it includes it includes the huge amount of water is required for factories for their production, working, manufacturing process, etc. Okay. Then next is here industrial. According to industries, give this a unit of population and water required for kilo like liter unit. Okay. Then next, demand of water for building other than residential buildings. This is hospital required, then 340 per bed, hotels, then restaurants 70 per seats, then schools 45 per head, hotels again 135 per head, then offices 45 per head. This all the charts shows, or all tables shows actual demand of water for the different purposes, industrial, commercial, etc. Then next is fire demand. So it is a very important demand. Okay, usually occurs in industrial areas and store causes serious damage to properties and life. Large quantity of water is required at always kept store in reservoir. Okay, this is the from these are 4 to 5 demands. Okay, from this 4 to 5 demand, among that 4 to 5 demand, for fire demand is more than all, because it's required suddenly, or it any time it required. Okay, so that's why we have to store the large quantity of water required, always kept stored in reservoir. Okay, this is the fire demand. So there are 4 to 5 formulas for calculating fire demand. Okay, they also mention in Cooling formula, then Freeman's formula, Government of India formula. We always use this formula. So Q is equals to 100 in root P. Okay, it's simple formula. Then Burstone's formula, and next is also used National Board of Fire under the Writer's formula. Writer's formula. So is the Q 463037 in root P in bracket 1 minus 0.01 in root P liter per minute. So all for all Q's. Okay, all Q is in liter per minute, but only one Q means Government of India formula. The Q is in between, is in kiloliter per day. So population always in thousands, measured in thousands. Then loss and waste. So loss and waste means what? It includes careless use of water, then leakage or in means unauthorized water connection, throwing of stored water. So leakage in main walls, other fittings. Okay, then careless use of water means unauthorized connections, etc. Okay, careless use of water, water if distribution of water is more. Okay, and consumer always waste that water. Okay, is the careless use of water. The quantity of water in leakage and wastage due to all these, it cannot be effectively predicted due to. Okay, then these are the ways water or loss and waste due to these all factors. Okay, that's why water meter system is used for this is the for preventive measures. Preventive measures, which are the preventive measures for careless use of water? So first is water meter is used for due to consumers always use the careless use of water, that's why we implement water meter. This is the one thing. And leakage in means, so maintenance in distribution system is always happen, that's why here one thing is again reduce means leakage in means unauthorized water connection. So water supply distribution has definite means fixed method is there, or fixed type for the distribution, means tree, then polygonal. After that there are different methods. Okay, radial method, they are all methods used for distribution. So unauthorized water connection is also eliminated. Then throwing of wastewater, throwing of stored water. Okay, this is also prevented by this वाटर मीटर सिस्टम. जो वाटर मीटर सिस्टम थी वो लगाने के बाद ये भी कम हो गया अभी थ्रोइंग ऑफ वाटर. और वी आर गोइंग टू डिस्ट्रीब्यूट द वाटर इन means in 2 to 3 days और इन रोटेशन पीरियड्स फॉर द रोटेशन. मीन्स होता है ना पीरियड होता है ना कि अभी 2 दिन या 3 दिन के बाद हमारे यहाँ पानी आता है वो कंज्यूमर यूज़ के लिए. सो दिस इज़ द थिंग, मीन्स कंटिन्यूस सप्लाई अगर उन्हें दे दिया जाए कंज्यूमर्स को तो क्या होता है, अगर डिमांड हुआ वाटर डिमांड कम हो जाती है. अल्टीमेटली द वाटर डिमांड विल बी रिड्यूसेस ड्यू टू continuous supply of water. If supply of water intermediate, okay, or discontinuous, then demand of water will be increases. Okay, so demand of water increases and this loss and wastage also reduces. Okay, these are all the remedies or preventive measures which we have to um, apply for reducing our water, okay, wastage of water. Then factor affecting on water demand. So in last session I already say that there are some different factors which are affecting on water demand. So like cost of water, then habits of people, climatic conditions, size of city, quantity, then quality of water, then metering system is there. Okay, then supply and distribution pressure, then industries and commerce, then system of supply, the system of sanitation. Here climatic condition. So climatic condition is the main fact that large quantity of water is required for big cities since commercial industrial development take place in there. Okay, then quality of water is required for flushing the system, and cost of water, then living standards of people. So per capita consumption is more for rich people than the poor and middle class people. Okay, then pressure in distribution system. So water demand increases with increases in the pressure of the water in distribution line. So and there will be more loss due to leakage depth. And cost of water, so the cost of water is less or minimum, then consumption of the water is more, means it's a vice versa. Okay, the cost of water is more, less quantity of water will be used. Then system of supply, continuous system of supply, consumption is more than the intermittent system. Then quality of water, if the quality of water is good, consumption will be more. Okay, then system of sanitation, per capita per demand of town having water carriage will be more than town where it is not used. After that, variation in demand of water to 4 reasons: seasonal variation, monthly variation, daily variation, and hourly variation. Okay, so means seasonal variation means demand varies from season to season, depends on season. So summer or rainy season. So in summer demand of water is more due to summer season, and after that during summer, okay, the demand of water is more, and during rainy season or in winter season demand of water will be reduces or less. Then next is monthly variation. So depends or varies from month to month, means in May, June, July, variation is more, means what, in this 2 to 3 months demand of water is more than other 8 months. Okay, then daily variation, day to day variation means, so demand depends on some factors, means habit of people, climatic condition, types of area, means industrial or commercial area. Okay, after this hourly variation, hours to hour variation, maximum demand. 7 a.m. to 9 a.m. minimum demand. Between 11 to 3 p.m. again maximum demand. Again maximum 7. So in between 7 p.m. to 9 a.m. is the maximum demand. Next is population forecasting. So it's a very important topic, and all things are depend on these population forecasting. There are 8 methods, okay, but some first 3 to 4 methods are very important for population forecasting, and mostly these methods are used. There are some criteria for using this method, okay. After this, the population forecasting means what? As I discussed in previous session about population forecasting, means to determine the future population based on the present and previous year population. Then what are the necessities of this? To determine the first, to determine the population at the end of design period. Then to design the various component of the water supply scheme. Then to design the components of water supply scheme for the future need. To supply the water to the present as well as future population. Okay. So this means the population is of every population of every city or town increases with time to time. Okay. ऐसा नहीं होता है ना कि अगर 2001 में population अगर 10 लाख हो और चलो 10,000 देते हैं, 10,000 population in 2001, is it same for the all 10 years? No, it's not same. Okay. In year means in a 2021 the population will be increases. Okay. एक तो वो increase होगी, okay, नहीं तो वो थोड़ा तो आगे जाएगी. ऐसे तो नहीं ना वही की वही रहेगा 10,000 to 10,000 ही रहेगी, ऐसे तो नहीं होता है ना. Okay, so it will be increases. That's why we are going to design any type of structure, any type of component in our public health engineering according to this population, means according to, means based on after 10-year population, not for present population. We are going to design any component for future, for future population. Okay, that's why we have to learn about population forecasting. That's why we going to calculate the population, okay, in next nth years. Okay, then that's why if the water supply scheme is designed for present population, it will be inadequate with a few years. Okay, वो कम हो जाएगी, उसकी जो efficiency है वो कम हो जाती है अगर हम 10 साल पहले ही डिज़ाइन करें. ओके, सो इफ़ आई वांट टू डिज़ाइन एनी, फॉर एग्जांपल लेते हम वाटर टैंक. इफ़ यू वांट टू डिज़ाइन वाटर टैंक, so what are we going to do here? If 2020 में कितना हो गया पॉपुलेशन, मानो वो होता है 20,000. Okay, if population is 20,000, what are we going to do? We're going with population 20,000 and design the all water tank structure for the 20,000 population. Is it feasible to use after 10 years, even after 5 years? No, it's not feasible. We can't use after 5 years this water tank. We need to construct again. We need to construct one more water tank, but it's not possible after 5 years. Okay, so that's why we have to do some work for future. Okay, so like that, all component of water supply scheme constructed once again cannot made a large or replace. Okay, larger or replace. So hence various components of water supply schemes are designed to the end of design period. Okay, this point you have to concentrate on this point. It's very important point. अगर आप किस प्रोजेक्ट को हाथ में लेते हैं, किसी भी प्रोजेक्ट को अगर आप हाथ में लेते हो और वो आपको डिज़ाइन करना है on the basis of public health engineering, related to public health engineering, then you have to learn about this population forecasting. You have to predict that population. ओके, इसके अलावा नहीं हो सकता कुछ भी. ओके, so there are different methods you're going to learn step by step. So arithmetic increase method, geometrical, incremental, decrease rate of growth method, simple graphical method, graphical comparison method, logistic method. Okay, then zoning method is there, the ratio method is there. So there are different methods for population forecasting. The first is arithmetic increase method. This method is based on the consumption, based on, okay, so the average rate of this is the arithmetic increase method. It is a very simple method. First of all, it's a very simple method, and from this method we are going to calculate the future population. Okay, so for this method we are going to use this formula: Pn is equals to P plus Nd. So what is the Pn? Pn is the population after nth decade. Decade means year. Okay, नेक्स्ट ईयर जे येतात ना, वो जो आते हैं ना उसको कहते हैं डिकेड. सो पॉपुलेशन आफ्टर nth डिकेड. देन p means present population. Then d is the average increase per decade, and n means number of decades. So there are some assumptions we have to consider in arithmetic increase method. So assumption is the first is the average rate of increase in population from decade to decade is constant here. Okay. Then from the previous census data, the increase in population between consecutive decades is found, and from these average increase per decade is work out. Okay, simple in simple is that this method is based on assumptions, so that the average rate of increase in population from decade to decade is constant. First thing, from previous census data, increase in population between consecutive decade is found out, and from these average increase per decade is worked out. So it's very simple. There are some problems on it, we will learn in the next section. And what are the suitabilities that I said that previous session, that there are some criteria, some limits, and after that we are going to apply this method. Okay, so suitability for the city or town. So first is design period is small, town is old and large. Okay, means no any scope for widening of that mm, means population. Okay, much score, not much score for widening population. Then also reach its saturation population due to max development. After that, geometrical increase method. So assumption is that the average percentage increase in population from decade to decade is constant. Here we want focus on average percentage increase. Okay, so and Pn is equals to P in bracket 1 plus R upon 100 raised to n. This is the next formula. This formula, these problems are very important for your exam point of view, for your project point of view. Okay, so the method is based on assumptions that average percent increase in population from decade to decade is constant. And again one more thing, from the census data of previous decade, percentage increase in population between consecutive decade is found out. The its average calculated. The future population after n decade is calculated by using this formula. Okay, this following formula. So the for next, okay, in that in this formula, Pn means present, P means present population, and Pn means population after nth decade, means future population after nth decade. Okay, R means average percentage increase in population per decade, and nth is number of decade. Then what are the suitability? So first is it's suitable for towns, okay, having large scope for expansion. In arithmetic method it's not possible because it required old towns, okay, old towns लगते हैं उसको अप्लाई करने के लिए, और वहाँ पर पॉपुलेशन का कुछ स्कोप नहीं होता है. ओके, सो हियर द टाउन्स हैविंग लार्ज स्कोप फॉर एक्सपांशन and fairly constant rate of growth is expected. Okay, then incremental increase method, this is the third method. And one more thing, there are also some problems on this method. So formula, remember formula is most important, so उसको याद कर लो. Pn is equals to P in bracket 1 plus R upon 100 raised to n. Okay, incremental increase method. So this method include arithmetical increase method, is also called as arithmetical increase method. So it includes advantages of both. Okay, it includes both method. Both method includes first arithmetic method, and the second is geometrical method. Both methods are included in in this method. This is the